Hello class, today we're going to talk about section 7.6, which is about percents of change. A percent of change is a ratio that compares the change in a quantity to the original amount. So that's a fancy way of saying we're looking at how different it was compared to what it originally was. Our formula here for percent of change is percent of change is equal to the new thing, so whatever we end up with, minus the original thing. That's our numerator that we have. That's our difference. Dividing by the original. That's how we compare it to the original. That's going to give you some sort of a decimal, and then you're going to multiply that by 100 to turn it into a percent. If it is a positive decimal, it is going to give you a positive percent, and we call that a percent increase. If it is a negative decimal, it's going to give you a negative percent, and we call it a percent decrease. When we use these percent increases and decreases, this is very practical when we are talking about retail businesses. So most of the time when you go to the store, the price you pay is not actually what it costs to make that item. So for example, it does not cost $600 to make an Xbox. But we have the selling price, which is what the customer pays for that item. A markup occurs when there is a percent increase and the store increases the amount of the item to make the consumer pay more. That's how they make profits. A discount is a percent decrease. That is where we are taking money off the price. Usually this happens when sellers are trying to get rid of merchandise that they don't want anymore. So we're going to start with just some basic percent of change problems. So our goal is to find the percent of change, rounding to the nearest hundredth, which is 2 decimal places. And then we also want to decide, is it a percent increase or a percent decrease? So first we're looking at 60 degrees Fahrenheit to 84 degrees Fahrenheit. Would be really nice if we had those temperatures right now instead of these single digits. So our 60 degrees Fahrenheit is our original temperature, and our 84 degrees is our new temperature. So to set up our equation, we're going to take the new, which is 84, subtract the old, which is 60, put that over the old, or the original, that's also 60, and then multiply by 100. From here, my advice to you is before you plug this into the calculator, you solve the numerator. So you solve 84 minus 60, which is going to give you 24. Now you can plug in 24 divided by 60 times 100 directly into your calculator. And when you do that, you get an answer of 40%. If you had typed into your calculator 84 minus 60 divided by 60 times 100 without solving the numerator, so just as it is written right there, your calculator would have given you an answer of negative 16, which is not the correct answer. What your calculator is doing is following PEMDAS, which is saying to do 84. It's treating this division and then doing the multiplication and then doing the subtracting at the end. So the key here is making sure that you are solving the numerator part before you plug it into your calculator. So make sure you solve that subtracting before you plug it into your calculator to get the answer. So we have 40%. If it is just asking for the percent, then that is your answer. You might also have them asking for percent increase or decrease, which is what we had here. So you would say 40% increase. If it so happened to have been a negative, so if we had flip-flopped this to the other way, and it had been a negative 24, we would have ended up with negative 40%. If it was asking just for the percent, you would say negative 40%. If it was asking for increase or decrease, you would have said 40% decrease, and you no longer need that negative sign. So depending on how you end up writing your answer, you either include a negative if there is one, or you don't. Go ahead and try this one on your own. So for this example, our original is our 318 and our new is 273. So we set up 273 minus 318 divided by 318 times 100. We do our subtracting, which gets us negative 45 divided by 318 times 100. You can either write that out as negative 14.15% to show that it is a percent decrease, or you can write out 14.15% decrease. So either way, showing that it's going down. The other pieces that we are looking at here is finding our selling price, so how much it's going to cost. So for finding the selling price, if a store pays $42 for a pair of rollerblades and marks them up 25%. Here they give us our percent, and it's saying it's a markup, so this is increasing the percent you are going to pay. So you as the consumer are going to pay 100% of the price plus the extra 25%, meaning that you are going to pay 125% of the price. We're then going to turn that into a decimal, moving it 2 places to the left, and we have 1.25. Then to find your final answer with the selling point, you're going to take your original price, which was $42, and multiply by the total percent you are going to pay, which was the 1.25. When you multiply those, you're going to end up with a selling price of $52.50. Remember, in your calculator, it just gives you 0.5, but money has 2 decimal places, so you need to add that second 0 in. So our selling price for this markup is $52.50. Go ahead and try this one on your own. So we add our 40% on, giving us 140%. Move the decimal over to 1.40 or 1.4. Multiply by the original price of $75, and you get a final answer of $105 for the selling price. On the flip side of markups, we have discounts. So this is taking away a percent that you are paying. So a volleyball net has an original price of $59. It is on sale for $65 off of the original price. We are trying to find the selling price, that sale price. So now we have 100%, and we are taking off 65%. That leaves us with 35% that we are going to be paying. Then we move our decimal over twice to convert it into the decimal form that we can use to solve the problem, which is 0.35. Then we're going to multiply that by our original price. So in this case, we have $59 times 0.35. And once we do that, we get our final selling price of $20.65. So the sale price means that you could buy it for $20.65. Go ahead and try this one on your own. Taking away your 67%, you're left with 33% that you're going to pay. Changing that to a decimal is 0.33. And then you multiply that by the original price and get $11.55 as the selling price. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.